solve x dy by dx equals y times y plus 1, x and y both positive, and you got some condition here. Differential equations, let's do it. So first thing with differential equations, always you need to get the x's together and the y's together, or whatever the letters are. It's called separating the variables. In this case then, well, that's a dy on the left at the top. That's absolutely fine where it needs to be. But these y's are on the right, so they'll need to divide down the bottom. Y plus 1 on the bottom. They've divided down. And on the right, you're multiplying the dx up. And this x has to also come across. And you get 1 over x dx. Now, why is it not just like adding or subtracting? That's not how you're allowed to do it. You have to get them across to the other side by dividing or multiplying. So you want, now we've got all the x's over here, having multiplied that up and divided the x, and we've got the y's on the left now. So we've separated the variables. It's always the first step of differential equations. Now we've got to integrate. That's easier. It's ln. It's one of the general integration rules that ln goes to 1 over x and 1 over x integrates to ln. Put a constant here. Technically there'd be a constant for, on both sides, I guess, because you're doing two integrals, but what's the point, right? You'd have a sort of second constant here, and then you just could bring them together anyway. Imagine that was 2 and that was 3, just bring it together, it'd be 1. Pointless, so just have one constant. Now here, how do we integrate that? Stare at it. Honestly, stare at that. It's partial fractions. Now, try and notice it. I know it's hard. They're not going to tell you that. They don't usually help you out, but even if it was like this on the bottom, that might be more obvious. It's more clearly partial fractions maybe, but it's just the same there. It's a factorized quadratic, and that's a trigger for a partial fraction situation. Let's do the partial fractions then. Shall we just do the partial fractions down here? Come on then. You've got 1 over y plus 1 has to be rewritten as a over y plus b over y plus 1. That's the structure for the kind of fundamental partial fractions one. If there's a squared at the bottom here, that might change what you've got here, but there's no squared, so that's all there is. Multiplying everything by the denominator, 1 equals a times y plus 1 plus b times y. Yep, that looks good. Then you want to sub stuff in, so we want to sub in x equals 0. When I do that, I'll get 1 equals, well, that'll go to 0. You just get a. That's quite nice. And then x, want to put in minus 1. Yeah, it's actually y's that we're putting in, not x's. I'll just change that. Yeah, y is 0 and y is minus 1. Yeah, when you put that in, that'll go to 0, and it looks like you're just left with b equals minus 1. You might want to check that yourself. So overall, you can rewrite 1 over y plus 1 as 1 over y plus, minus 1 over y plus 1. A is 1, b is minus 1. So using that on the left-hand side of our integral then, it turns our integral into integral of 1 over y minus 1 over y plus 1 for the left-hand side. The right-hand side, we've already done it. It's ln x plus c. These are also log integrals. That goes to ln y minus ln y plus 1. Wow, love that. Love that for us. We've done it. We've done the integration. Good, but we're not finished yet. It's not looking the neatest, it's not looking the simplest, and it certainly isn't y equals. Ideally, I want to get this as y equals. Let's keep going then. Log rules, when you've got a subtraction, you can divide. So that'll be ln of y over y plus 1. By the way, you can't just undo the logs here because there's a minus and a plus. So you can't just do e to every term individually. You've got to bring them together first. Or if you are going to do an e, I'll show you in the next line of working what's going to happen. Because here we're going to do e to the power, and that's going to undo this ln, e to the power, e to the power. But we can't just undo that ln because of the plus. I need to use a little trick here. That you can rewrite as, using power rules, if you think about it, e to the ln x times e to the c. Think about how power rules work. If you've got two things added in the power, then it's like separately multiplying them. I mean, x squared times x cubed is x to the 5. You've added the powers. So you could go backwards and write it like that. Now, why? Well, e to the c. Well, c is a constant. We don't even know what it is. I mean, why? Why bother keeping it like that? Just redefine that as a, or any letter you want. And, you know, this right-hand side becomes a e to the ln x. All right, a times e to the ln x. Then the e and the ln cancel, and you've just got a times x on the right-hand side. It's a classic little trick where, with these exponential ones, happens quite a lot in differential equations. If you've got e to the power involving c, redefine your constant, and it takes a much nicer form. So all of a sudden, we're dealing with y over y plus 1 equals ax. And actually, we've managed to, you know, greatly already simplify from this line to this line of working. Yep, nice little trick over here, something you want to know about and be able to use. Pretty much done. The last thing then to do is, well, two things. One is to get the a, and the other thing is to get it in the form y equals. Let's get the a first, just because I'm feeling like that today. Feeling like a bit of a action. So let's sub the stuff in, a half and blah blah blah. So if we put it in, you'd get a half over a half plus 1. That's 3 over 2. And on the right hand side, apparently that equals a third a. Wow. Well, 2's are cancelling. Are you absolutely kidding me on? Because look, if you times by 3, whew, a is just 1. Mildly confusing having an a as a constant here and an a are partial fractions, but I think we'll cope. I do think we'll cope. So overall, a is 1 then in our case. So in our case, it actually looks like y over y plus 1 equals x. Would you believe it? Beautiful. So pretty much done, to be honest. You could even leave it in that form, depends what the question's asking for. But we want to push it all the way. Let's get it y equals x times y plus 1. I'll just do this and then I'll do as a quick recap of the whole question, turbo one. There you go. Bring that over to the left and actually pull out the y at the same time. And then just divide it through and you get y equals x over 1 minus x as your final answer. Turbo recap. This is what they gave us to solve. It's a differential equation. We notice it's a differential equation because there's x's and y's absolutely everywhere and there's a dy by dx in there. Could be different letters. Whatever the letters are, the first step is always separation of variables. Get the dx's with the x's and the dy's with the dy's, and you do that by multiplying and dividing. Here we divided these y's down the bottom and divided the x's down the bottom. Gave us this structure. Right hand side went to ln, left hand side you need to notice it's partial fractions. Then you need to have your partial fractions skills at hand. Change to 1 over y minus 1 over y plus 1. That's easier to integrate, it's just logs. And it's not controversial logs in any great way. Cool, you got here. Still need your log and exponential rules. Well, these two things come together. All right, that's nice, because when you do e to the power, it undoes the ln now. It wouldn't have done it because of that minus sign before. And you do have that problem with the plus sign here, that it's not just, you can't just cancel it and say x plus c, but it's not the right vibe. What is the right vibe? Just think about the power rules, redefine a constant e to the c as a, and this can then simplify to a times x. Whew. What is a? Well, sub the stuff in and it was 1. Whew. Someone was kind in writing that question with the numbers or whatever. 1, and then last thing, just rearrange it. You get y equals x over 1 minus x. Not a bad little example. Save it for your A-level, save this video for your A-level revision. Subscribe, I'll put more of these up. Have a lovely day. Thanks, guys.